Hey, hello, good afternoon, dear Swift learners. How are you all? I hope that you all are safe and sound and very much fine at your homes. And I, Ritika, am back with another new session. And before telling you what is our today's lesson about, we will have a quick tour around Swiflearn to see what is Swiflearn all about. So Swiflearn, it is India's most sincere learning destination, wherein we provide the classes for grade 1 to grade 10. So over here you will have 100% live interactive classes, plus you will have personalized attention batch with 6 students maximum, and apart from the teachers you will also have academic mentor team which will be guiding you and which will be tracking your progress. Also, we cover your syllabus as per your school exam schedule so that you can perform amazingly well there also. So these are some of the main features. Apart from these, Swiflearn also have some of the special features like detailed progress report. That is, every month your progress report will be generated over here and you will get to know what are you doing in your test, in your homework, in your classes. So everything is listed over there. Also, you can take unlimited practice tests which are available on the Swiflearn portal, which also include subjective tests. And you can also participate in the Swiflearn academic test series, which is a kind of scholarship test. Okay, so all these things you will be getting. All you need to do is just download the Swiflearn app and book your very free trial class. So everything you can yourself see. Alright, and kindly subscribe to the channel of Swiflearn so that you do not miss out on any video, because amazing lessons go on here. And you can also press on bell icon so that you get your updates. And if you like this video, press on like button. So we completed and we just did the first session of language of chemistry, in which we learned about some of the basic terms of chemistry, right? And today we are going to take this chapter forward and we are going to learn a bit advanced things, alright? So today we are going to learn what are the conditions required for writing a chemical reaction. Then we are going to see what is meant by a chemical reaction. Also, we are going to see what is meant by skeletal chemical equation and how to balance a chemical equation. So these are all of the things that we are going to see today. But before that, let us see what we have learned previously. So in our last class, we learned about what is meant by a chemical reaction, what are the chemical changes, and we focused on exothermic and endothermic reactions. Alright, so we will have a quick revision on all of these things so that you got to have a quick revision. Okay, so what is meant by a chemical reaction? So it is a kind of reaction in it is a kind of process in which the reactants, okay, the reactants are the substances which take part in any reaction. They combine to form products. Okay, so many things they combine together and they form a new product. So when they form a new product, when the reactants combine to form a new product, we say that a chemical reaction has taken place. All right, we can say it as, just a minute, yeah, so reactants, there may be one, two, or many, they give out products. So this is what a chemical reaction looks like. Then we have exothermic and endothermic reactions. So what are exothermic reactions and what is meant by endothermic reaction? So exothermic reactions are those reactions which give out the heat. Okay, they give out the heat in the environment, and endothermic reactions, they take in the heat from the environment. Okay, they endo means in, so they take in the heat. Now, what are the conditions required for a chemical reaction to take place? So there are various things which are actually required for any chemical reaction to occur. Okay, first of all, close physical contact of reactants. Next, we have solution form of reactants, supplying energy to the reactants, applying pressure on the reactant, and use of catalyst. So we will be discussing every single point in detail so that you got to understand why are these points very essential. Let us see. Let us begin with close physical contact of reactants. Now, let's see if this is my first reactant and this is second. Now, how will they react if they are not in physical contact? Okay, so for any reaction to take place, it is very important that a reactant is close to other. Okay, so if I talk about small pieces or powdered solid reactants, they have larger surface area which enhance the speed of reaction. Okay, so the close the reactants are, the reaction will be occurring more easily and more efficiently. Now if I talk about sodium, it is dropped in water. Okay, so if we drop sodium in water, water and sodium, they come in contact with each other, and because of that it reacts vigorously and it forms sodium hydroxide and hydrogen gas. So here Na stands for sodium, H2O is water, so it reacts and they form sodium hydroxide and hydrogen gas. Okay, so this is the kind of reaction you can see. It is very vigorous reaction. Okay, so when two substances they come in contact, it has this reaction. Next, if I talk about potassium metal, so potassium, what does it do? It reacts very rapidly again with water, and it forms the solution of potassium hydroxide and again hydrogen gas. So we learned in our last class that upper arrow, it is for any gas which is evolved. Okay, and if the arrow is showing downward, it means it is forming a precipitate. Now next topic is solution form of reactants. Now many times what happen, when reactants are not mixed, the reactions do not happen very perfectly. Okay, so some reactions they take place only when the reactants they are in soluble form, liquid form, okay, in solution form. Okay, so this close contact can happen very easily when the reactants are in solution form, and there are two examples of solution form of reactants like precipitation and neutralization. Okay, so in these we need a solution. For example, let's take about precipitation reaction. So precipitation, the word itself is telling that there is a precipitate which forms. Okay, so it is actually formation of insoluble salt when two solution containing soluble salts are combined. Okay, so if I talk about iron sulfate and sodium hydroxide, these are aqueous. Aqueous means they are in solution form. So when two soluble salts they are combined, it is forming one insoluble salt. Okay, so iron hydroxide, it will form a kind of precipitate. Okay, it will not be soluble. Next, neutralization reaction. Now neutralization means when one acid and one base they react to form salt and water. तो न्यूट्रलाइजेशन रिएक्शन क्या होगा हमारा, when one acid and one base they react together to form salt and water. For example, sodium hydroxide, it is a base, just write it here. So it is a base. Then we have hydrochloric acid, which is an acid. So they are combining to form salt plus water. Okay, so this is the neutralization reaction. Now if we pour base and acid, okay, and it forms salt and water, that reaction is termed as neutralization or acid base reaction. Next topic is supplying energy to the reactants. So normally what happens, we apply heat energy to the reactants for any chemical reaction to take place. Okay, so mostly we do it in form of heat energy. So on heating the reactants, their particles, the collision occurs very frequently, okay, which actually is due to increase in kinetic energy, and that is how the reactants are, reacting very properly, we can say. So if we heat zinc carbonate, it produces zinc oxide and carbon dioxide, and it doesn't happen if we don't heat it, but if we provide heat, that is if we supply the energy, it will convert itself into zinc oxide and carbon dioxide. Now also we can provide them the energy in form of light. Okay, some chemical reaction they take place in presence of light, and these are known as photochemical reactions. So photo means light, so photochemical reactions they are known as. Okay, now the molecules of the reactants, whatever the substances we are using them to react, they absorb the light energy, they collide, and then they react. For example, if I talk about hydrogen and chlorine, and if you provide sunlight to them, it will lead to the formation of hydrogen chloride. That is, it is using the light energy. Now same cases with photosynthesis. Okay, so what happens, the plants take in carbon dioxide and water, okay, and we have sunlight and chlorophyll, okay, so they use it to form glucose and oxygen. So this whole process it is known as photosynthesis. Okay, so here again light energy it is given by sun. Okay, so carbon dioxide plus water, they react in the presence of sunlight and chlorophyll to produce glucose and oxygen. Now sometimes we also give them energy in form of electricity, like electrical energy, okay, and that is known as electrolysis. So there are some decomposition reaction that can be brought about by passing electric current through the reactants. Okay, so whenever we pass electric current through the reactant, okay, so electrolysis happen. Okay, so mainly our reactants in this electrolysis reaction, they are in molten state or aqueous solution. Okay, and इनकी वजह से क्या होता है, we get the ions. For example, if I talk about electrolysis of acidified water or molten sodium chloride, let us see. Now, if I talk about acidified water, so over here what will happen if I pass electricity, तो जो water है, water is combined of H2O, so hydrogen and oxygen. Okay, so here our water, it will dissociate into ions of hydrogen and oxygen. Similarly, if I talk about molten, that is liquid sodium chloride, it will again give chlorine and sodium. Okay, so it will give the ions of chlorine and sodium. So sodium will be in metal form and chlorine will be evolved as a gas. Next is sometimes we also need to apply the pressure on reactants. Okay, so some chemical reactions, they take place on application of pressure. Okay, and that is the most common example is Haber's process to form ammonia. So we will be seeing how does it happen. So what happens actually, high pressure, it allows the reacting molecules, whatever molecules are reacting, it allows them to come closer. Okay, and they can collide with greater intensity and hence they can react properly. Okay, now see, if I talk about formation of ammonia by Haber's process, what is happening? We are combining nitrogen and hydrogen on a very high pressure. Okay, here iron is acting as a catalyst. So catalysts are those substances which do not actually take part in the reaction, but they speed up or speed down the rate of reaction. Okay, so nitrogen and hydrogen combine in the presence of iron as a catalyst with a high pressure, okay, to form ammonia and heat. We are going to see the process how it happens. Okay, so this is a kind of chamber where hydrogen and nitrogen gases, they are combined. Okay, so this is compressor which is giving great pressure. Okay, so after that the gases will pass over here. Okay, here iron is present as a catalyst which speed up the reaction, and now over here, okay, we will get the liquid ammonia. Okay, so whichever ammonia we have gotten, we are just taking it out, and it is also possible that sometimes unreacted nitrogen and hydrogen gas are still present, so it will again go from here and again the same processes will follow. So basic thing in Haber's process is we are applying great pressure with presence of iron as a catalyst. Now, what is the use of catalyst? So what happens, catalyst main use is to alter the rate of chemical reaction. Catalyst क्या करेगा, या तो rate of reaction को बढ़ा देगा या उसको कम कर देगा, but it never takes part in the reaction. Okay, तो जब कभी reaction हमारा end हो जाएगा, then also our catalyst will be there. Okay, now catalytic oxidation of ammonia. So an ammonia mixture overheated platinum forming oxides of nitrogen which produce nitric acid when absorbed in water. Now what is happening? Ammonia, when it is combined with oxygen over here in the presence of platinum. So platinum here, it is acting as catalyst. Okay, so it gives out nitric oxide, water and heat. Now positive means we have two type of catalyst. Positive means which increases. तो जो catalyst किसी भी reaction के rate को जल्दी कर देते हैं, which increases the rate, it is known as positive catalyst. Like if I talk about potassium chlorate, in which manganese dioxide is used as catalyst, we will get potassium chloride plus oxygen. तो manganese dioxide से क्या हो रहा है, ये reaction फटाफट से हो रहा है, it is increasing the rate. And negative catalyst, they slow down our reaction. Okay, so if we have hydrogen peroxide and if we here use phosphoric acid as our catalyst, तो जो reaction होगा वो थोड़ा slow हो जाएगा. Okay, we will get the byproduct slowly. So water and oxygen we will get a bit slowly. Now promoter, so the substance which increases the efficiency of catalyst. Now catalysts are used to increase or decrease the rate of reaction. अब उनका भी जो efficiency है वो increase करता है promoter. Okay, so we can say promoter is catalyst of catalyst. So molybdenum, it acts as a promoter. तो क्या हुआ, जैसे nitrogen and oxygen we are using to form ammonia. Okay, so iron works as catalyst. Now what molybdenum does, it increases the efficiency of iron. Okay, so eventually it is again catalyst of catalyst. Okay, so it promotes, okay, it promotes the rate of reaction. Now talking about chemical equation. So what are chemical equation? Now we cannot be writing, like if I want to write that hydrogen and oxygen are combined to form water, I always cannot write the whole sentence. So what the people did, they came out with a solution to use symbols, and using those symbols they made chemical equations. Okay, so rather than writing the full sentences, we just use the symbols to write the chemical equations. Okay, now what does a chemical equation contain? There are two parts. The left side, it represents the reactants, whichever substances they are taking part in chemical reaction, and right part, it have products. Okay, whatever we are getting after the reaction happening. And this arrow indicates that here this arrow is separating actually the reactants from the products. Okay. Now, whenever we are writing any chemical equation, there are certain rules that we should remember. So first is write the correct name or correct symbol or formula for the reactant on left side. Now if I talk about correct symbol, okay, now N stands for nitrogen and Na stands for sodium. Now if we miss N, the whole meaning of our reaction will change. Okay, so it is very necessary that you should be knowing the symbol of all the elements, okay, and you should be using it correctly. Now put a plus sign in between the reactant if two or more reactants are participating in the chemical reaction. So if you know more than one thing reactant is present, then put a plus sign. Okay, like if I talk about H2 plus O2. Okay, so here we are using plus sign. Then write the correct name, chemical symbol and formula for the product on right side also. So that applies for right side also, that we should be knowing and writing the correct name or symbol. Now again, if on the product side we have more than one product, just write plus sign. Okay, put a plus sign so that we get to know that there are 2 or 3 separate products forming. And the arrow sign, it actually separates product from the reactants. Okay, and if there is any catalyst that we have used or any particular temperature that we have set, then we can even write that thing on the arrow mark. Okay, now if there is a reversible reaction, like a product can again change to reactant, we will be using double arrow, like X plus Y, it gives A plus B. Okay, so this is the arrow. Now let's see, it happens on 100 degrees Celsius. So we will be writing it over here, and if it is reversible reaction, we will again put a back arrow over here. Okay, and next thing that we learned is for any gas that evolves, we will be using this arrow, upward arrow. It stands for gas evolution. Okay, and whenever precipitate forms, we write for this. Okay, so that means precipitate. It has, okay, yeah, so upward arrow, it is for evolution of gas, and downward arrow, it is for formation of a precipitate. Now let us write chemical reaction in word format. So Mg stands for magnesium, O2 stands for oxygen, so they combine to form magnesium oxide. So rather than always writing these whole words, we go on for symbols. Now, okay, what is main important thing that we should be taking care of over here is the number of reactants or the number of products. They should be equally same. Okay, it should not be like 2 atoms of hydrogen give only 1 atom of any particular product. Okay, so we should always be careful about that. For example, let us take an example, PbNO3, so that stands for lead nitrate, and when it combines with potassium iodide, it gives lead iodide, downward sign, it is for the precipitate, and KNO3, that stands for potassium nitrate. Now over here there is one thing that you need to observe. Yeah, the number of lead atoms will be same on both the sides. Similarly goes for nitrogen, oxygen, potassium, iodine, everything. Let us see how. Now talking about skeletal equation. So what is a skeletal equation? An equation in term of symbol and formula. So there are no words over here, there will be some of the symbols, there will be the formula. Like a formation of water, so hydrogen and oxygen, they combine to form a water. Okay, now there is one mistake over here. This is unbalanced. Unbalanced means the number of atom on the reactant side, if it is not equal to the number of atom on the product side, the equation it is said to be unbalanced and it is considered as wrong. So for an equation to be completely correct, what is important कि जो जितने atoms हमारे reactant side पर है उतने ही product side पर भी होने चाहिए. Like if I talk about A to B, this is my reactant. Okay, so here I should be A plus B if it is dissociating like this. So here A has 2 atoms, so here also I should be having 2 atoms of A, and B has 1, so obviously it is correct. So this is the thing that we need to keep in mind. Okay, now H2 plus O2, it gives H2O. Now over here let us see. Hydrogen we have 2 atoms, oxygen we have 2 atoms. Now on the product side, hydrogen H2O. Okay, so H2 means 2 atoms of hydrogen, that is perfectly correct. But oxygen we only have 1, so that is unbalanced. Okay, now we need to balance it. Okay, so what are the steps to balance any chemical equation? First of all, count the number of hydrogen and oxygen atom on both the sides. Okay, now talking about reactant, here we have 2 atoms, oxygen we have 2 atoms. And talking about the product side, hydrogen obviously we have 2 atoms, but in oxygen side we have 1. So it is not balanced and we need to balance it. Okay, now there are 2 hydrogen both in reactant product, so there is no need to touch that. But about oxygen, there are 2 on reactant but only 1 in product side. So what do we have to do? We have to make 2 oxygen atom on the products. So what we will do, we will multiply H2 by 2 and write it as H2O. Now again we will multiply H2O by 2 and write it as 2H2O. Now how does it happen? Let us see. We had this reaction H2 plus O2, it gives H2O. Okay, now there are 2 atoms of oxygen over here and we need to have 2 here. So what we will do, we will write 2 over here. Okay, तो कितना हुआ? Now 2 into O, so O2. Now O is balanced, oxygen is balanced, but here 2 into 2, it becomes 4 atom of hydrogen. Now we need to balance this one again to have this full equation balance. So again 2H2. Okay, now see, reactant side per hydrogen kitna hai? 2 into 2 we have 4. Okay, and on the product side we have 2 into 2 again 4, so that is equal. Again talking about oxygen, so on reactant side this is O2, so again 2 atoms, and on the product side 2O, that means 2 atoms. So now it is completely balanced equation. Okay, so this is how we balance a chemical equation. Now for balancing chemical equations, what are the things that we need to observe? We need to observe how many atoms are taking part in the reaction on the product side and on the reactant side, and we have to balance them accordingly. So first of all, it is better if we write how many atoms are taking part and then we multiply or divide accordingly. And what are the symbols used to denote physical state in these equation over here? So if we talk about a solution, like if there is H2 and we write G, so G means gas. Okay, if there is L written, which means it is in liquid state, and S is for solid state. And aqueous solution, when it is mixed with a liquid, okay, it is written as AQ. Now if I talk about balancing this equation, now see, Fe plus O2 equals to Fe2O3. Now see, on the reactant side we have Fe1 and on the product side we have 2. And talking about oxygen, so on the reactant side we have 2 and here we have 3. Okay, now what do we need? First of all, we need 2 over here, so we will just add 2. Okay, so that is balanced. Now if I talk about O2, so here O is we are having 2 atoms and here we are having 3. Okay, so what we will do, we will multiply it by 3. Okay, so we will have 3O2. Now we again need here 6. Okay, so 3 2s are, we are having 6 atoms of oxygen over here. We again need 6 over here, so we will multiply it by 2. So for oxygen we are having 6, but for iron we are having 2 into 2, 4. So for taking 4 over here, what do we need to do? We need to again correct it over here. So it will be 4Fe plus 3O2 equals to 2Fe2O3. So it is 4, sorry, yeah, so 4Fe, just write it over here, 4Fe plus 3O2, it gives 2Fe2O3. Now we can count 4Fe here, 2 into 2, 4Fe here. This is balanced. So Fe is done. Then 3O2 means 6 oxygen atoms, and 2 into 3, 6. So this is also balanced. So this is how we need to balance the chemical reaction. Now, interesting facts: rockets are propelled by the reaction that occurs when liquid hydrogen and liquid oxygen are combined. So this is the reaction which goes on when we are propelling the rocket. Then solid form of carbon dioxide. So when carbon dioxide solidifies, it is known as dry ice. And bromine and mercury, they are the 2 elements that stay liquid at room temperature. Now, what information do you get from the equation H2 plus Cl2? It gives 2HCl. So here, see, first of all, G stands for gas. Okay, here also and here also. Next, we get the information of atoms. So here 2 atoms of hydrogen, 2 atoms of chlorine, they are combining to form hydrochloric acid. Okay, hydrogen chloride, again 2 atoms. Okay, and then we have plus sign because we have more than one reactant. Okay, so this is the thing that we get. Okay, now challenge of the day: select the correct answer A, B, C or D for each statement given below. Okay, so the black residue obtained on heating copper carbonate. So what is the correct answer from A, B, C or D? So copper oxide will be the correct answer. So we'll just write B over here. Next, the basic gas obtained when 2 gases react in presence of a catalyst and the reaction is exothermic. Exothermic means it is giving out heat, so it will be hydrogen gas. So this is the basic gas which is always evolved. The gas obtained when potassium chloride, it is heated in presence of a catalyst. So whenever potassium chloride we heat, we get oxygen as product. Okay, and a gas which reacts with oxygen to give a neutral liquid, so that becomes our ammonia. Okay, so this is our answer. And now talking about the activity of the day. Okay, so balancing a chemical reaction or chemical equation, it is based on which law? It is based on law of conservation of mass. Then we have the catalyst which increase the rate of chemical reaction, it becomes positive catalyst. Okay, and at the last we have the chemical equation which is written in term of symbol and formulae, so that is known as skeletal equation. Alright, so these are our answers. Okay. Now, what are the things that we discussed today? We discussed about the conditions which are very much required for chemical reactions to happen. Then we learned about chemical equation, how to balance a chemical equation, and what is known by a chemical equation and how to balance it. Okay, and what is known by a skeletal chemical equation. So I hope you might have understood everything that we have studied today. We will be meeting in the next session with more knowledge on this particular topic. Till then, keep studying, keep learning, and if you have missed out on any video of this particular topic, you can go and see that everything is listed on the Swiflearn channel, and you can also book your free trial class. So keep learning. Till then, we will be meeting in the next session. Please keep revising, and yeah, so thank you very much.